So hello guys, hope you guys are all well and having a great week. So tonight Middlesex University Product Design Engineering and Design Engineering are really excited to host our 16th talk in the annual guest lecture series. So these guest lectures, they run weekly throughout the academic year on Thursday evenings, and we bring together a vibrant mix of speakers from across the full spectrum of design and engineering. Tonight we're excited to host Alex Zivanovic, who many of you know from Middlesex. So Alex has been at Middlesex for over 12 years now, working across both product design and design engineering. He's been a lecturer, senior lecturer, and previously the program leader for the design engineering suite of programs as well. And now in his current role as a technical tutor in the Department of Design, Engineering and Mathematics. So Alex's background is really interesting and diverse. His first degree was in computer systems engineering, followed by a master's by research in electronic engineering, and then a PhD in mechanical engineering at Imperial College London. In this talk, Alex is going to describe his career in engineering and design and give him some insights and advice based on his experience. So in particular, he's going to talk about postgraduate research, how postgraduate research can lead into working in academia. He's going to describe some of the projects he's undertaken and worked on in medical robotics, medical training systems, robots, and kinetic sculptures, alongside some speculative design projects as well. So details of the talk and Alex were sent to your emails ahead of the lecture today, including links to Alex's LinkedIn, his Twitter, and websites as well. So definitely feel free to connect and browse as well. And without any further ado, with the talk title, Alex Zivanovic, A Design Engineering Journey. Alex, it's all yours.
Right, thanks, Ahmed. I just realized that I've given you a web URL. I don't think I've updated my website in years, but never mind. So yeah, as Ahmed says, I'm just going to go through my career kind of chronologically and just sort of pick out a few things here and there that I thought might be of interest to you. It's in no means kind of comprehensive. That would be way too boring. But a few sort of interesting points here and there. Do feel free to interrupt if you've got a burning question. Otherwise, you've got questions at the end and so on. So I'll just set my timer. Yeah, okay. So so I was born in London in 1970. In fact, I was born in the room above which I'm sitting in right now. Not born, well, I was born in the hospital about a mile away, but I spent the first couple of years in the room upstairs. So I haven't really gone very far physically. My dad was a mechanical engineer, a mechanical design engineer. He designed machines, factory automation type things. My mum was a school maths teacher. So I could say, you know, I was pretty obvious which kind of area I was likely to end up in. I went to school locally here in Ealing and in Hammersmith, again, about a mile and a half that way. And I've stayed around here most of my life, apart from going off to uni. So 1981, so age about 11, I started to program computers in Fortran. This is just kind of to show how far things have moved. In those days, it was right on the cusp of home computers. They hadn't quite come in yet. And so we didn't have a computer at school, of course, you know, who did in those days? Very, very rare. So my physics teacher set up a programming club where he taught me and one other guy who were interested how to program in Fortran, which is this programming language that has been around a long, long time. And because we didn't have a computer, we had to write our programs in fountain pen, and it had to be fountain pen. So we had to practice our cursive handwriting. And we had to write our programs in fountain pen on a bit of paper. And he would go into Imperial College in the evening because he studied there, I think, or somehow had access to the mainframes there. And he would go in, he would take our handwritten programs, punch them onto punched cards, and I still have a stack of punched cards. I should have brought them for this. Punched cards used to be about this kind of that big with holes inside, and each punched card had a line of programming, and he'd run it through the computer and bring back the output the next evening, where we'd sit down after school and go through the errors, because he wouldn't correct any errors you wrote in your program. So you had a 24-hour development cycle. If you missed out a comma in your line of programming, he would tell you the 24 hours later, the next day, and you'd be like, oh, couldn't you have just corrected that? But it was very good kind of discipline of learning to program. So things have gone a long way since then, you know. I recently, clearing up my house, found a book where Imperial had an open day where we could actually go and see the computer. And this was amazingly exciting because I'd been programming the computer for like 2 years and I'd never actually seen the computer. So they took us on a day trip and we walked into this room where there were these stacks and stacks of punched cards going through the machine and the printer bam, 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 printing stuff out. No screens or anything like that. It was quite something. So that I just thought that would be an interesting anecdote. And then, of course, a few years later, we had things like the ZX Spectrum, and in particular, the BBC microcomputer, and our school had some of those. Our school had tried setting up a computer lab, but the headmaster at the time thought that computers were a passing phase and that it wasn't worth investing in them because they would be gone in a year or two's time. But I got programming on the BBC Micros, in BBC Basic. I formed the school robotics and control club, and we programmed Fisher Technic and made robot arms like that, and did sort of, I even started doing sort of elements of kinematics in there, which is kind of geek, incredibly geek. And in fact, yes, I was the only member of this club. I couldn't find, even in a fairly geeky school, I couldn't find anyone to join me. So that was, I did that after school. Good way to spend an evening. So what lessons from that? I've got these lessons poked. None of these are particularly kind of earth-shattering, but just things to bear in mind that some interests stay with you for decades. I'm still interested in most of the things I was interested in when I was about 10 years old, which is kind of weird. And these interests come and go, and they pop up sometimes in the weirdest places. I always got interested in really strange things. So just have a wide range of interests, because you never know when they do come back and to help them, or you get back into them later. Technology keeps changing all the time. If you're going to go in anything, especially in this kind of area, when I look back on the punched cards and writing programs in fountain pen, I seem ancient, and I suppose it is ancient. It's 40 years ago, but it just seems such a long time ago. And if you don't keep up with that technology, you will get left behind. As I said, my mum was a maths teacher in school. When I was about 12, 13, they got their first computers in their classrooms. And I went in to set it up because they didn't have anyone at the school to set up the computers. And I literally moved an old mechanical calculator on the desk to make way for this PC coming in. And the teachers were completely kind of puzzled by all of this technology. And you've really got to, you've got to keep up with the technology, otherwise it just gets old very, very quickly. But the good thing is, even though it gets old and obsolete, the basic principles still apply. That robot arm I built, it's that the basics of that hasn't changed. The program might have changed, the hardware you're running it on hasn't changed, but the principles behind what you're actually doing haven't. So when I finished school a year early for various reasons. Our school was a bit strange. So I finished when I was 17, and I didn't want to go off to university before I was 18. That would have been a bit weird. So I took a gap year long before gap years became fashionable. And I worked at Texaco, the oil company, in the exploration and production department. So we dealt with North Sea oil rigs. And I shadowed a senior engineer there, and I went into sort of project meetings with him and ended up writing specifications for subsea oil equipment. Bizarre. And I wrote a database system to keep track of paper documents. In those days, pre-email, there was masses of paper documents that got circulated around engineering departments, and you had to keep track of where the document was, because if somebody needed to read it, you had to find out whose desk it was lying on. So I wrote something in Lotus 123. That's going back a bit. But it's not exactly what I planned to do. I had no intention of going into the oil industry. It's just my friend of my parents worked there, and she told me of a scheme coming up that I could join, and I did that for a year. So after that, I went to the University of Kent at Canterbury, nice campus university. I wanted to go away from home to go to uni in the days when we still had grants where we actually got money to go to university rather than having to pay money to go to university. We even got grants to live on and no fees and all of that. It's amazing looking back on it. Lovely place to study, really enjoyed it. I did a BSc in computer systems engineering, which was a mixture of electronics and computer science, because I really wanted to go into robotics even then. My other love was astronomy at the time, but my maths wasn't up to it. But I wanted to go into robotics, and I thought computer systems engineering was a good one because it was a more general degree, and so I could go in either direction, so hedging my bets really. You could see from those years, 1988 to 92, that's 4 years, and that's because I spent a year in Germany on the Erasmus program at the Rhein-Walische Technische Hochschule Aachen. As the speaker we had a couple of weeks ago on robotics, she studied there, but it turns out she studied there. She was born after I studied there, which is kind of a bit galling, but an interesting place to study. Huge technical university, massive. Their robotics department was the size of the college building, maybe even bigger. It was a huge industrial robot facility, and it was an interesting year. Really enjoyed it. Sometimes, not at other points. The language was a real issue. I had to learn German in the year before. I didn't know German the year before when I decided to go, so I had to do a sort of crash course in German, and the lectures were in German, of course, and I had to do a project in the robotics institute, simulating a robot arm, actually. But take an opportunity to travel if you can. I realize I'm privileged to do it, but if you can go abroad, do, because it really does open up your mind to other ways of doing things, living in another country, learning another language. I was pretty terrified going there. My level of German was pretty bad when I arrived, and just sort of working out, sort of living there for a year. But I made friends and I had a good time as well. So after my undergraduate, I ended up staying on to do a master's because I really got into my final year project. Which was a walking robot, a 6-legged walking robot, and in particular the software to control it, not having it sort of centralized control, but distributing control. So I ended up doing an MSc by research, developing a 6-legged walking robot in a program called Occam running on transputers, which is a technology long gone. So I just wanted to talk a little bit about masters and PhDs, because I think we've had lots of guest lectures, but we've never really talked much about the actual, what is it when we talk, say, I've done an MSc, I've done a PhD, and you might not know. And, bear in mind that all of you could go on and do a master's or a PhD if you want. I know a couple of years ago, some product design students came up and said, oh, we didn't realize we could do a research degree afterwards. And we were like, yeah, of course you can. Every academic subject can. And in fact, Ahmed can talk to you about that kind of thing as well another time. So you can do a MSc you can do a taught MSc, which is quite common, where it's like your undergraduate degree. You go to classes, you have assessments, you have a sort of major project at the end, and it takes 1 calendar year, normally full 12 months. But I did one by research, which was basically spending a year taking my final year project and expanding it. So what does research mean in this case? Well, it was looking at so I was looking at how you could distribute control for robots. So use parallel processing to run a robot. So rather than sending a really sort of rigid program of movements to this walking robot, I had a network of blocks of code communicating with each other to kind of, the coordination would arise from the way these things communicated with each other. So I spent basically a year in the lab. We had a lab at the University of Kent where I could do this, and I went in every day and experimented. So I did some programming on transputers. I designed and made printed circuit boards. I spent a long time using a PCB design package called OrCAD, where you lay down tracks on a PCB, and they were red and blue, or red and green, one for each side of the board. And I spent so many days doing that. I actually I remember having a dream of red and green lines, doing this in my dream. So when people say, do you dream in color? I know for sure I can dream in color, because I dreamt about printed circuit boards, because I'd stared at the screen way too long. And at the end of an MSc by research, you produce a thesis, and I still have mine. I'm not sure if you can see that nice hardbound thesis from sort of writing. It's basically like your final year project report, but longer and in more depth, and kind of talking about what you've done and exploring some of the concepts you've looked at. Yeah, doing kind of distributed programming in that. So that was my MSc. Very enjoyable. Again, I was lucky to be funded for that. I found some funding that paid for my fees and for my living expenses. So I was really lucky. I think it was just easier in those days in terms of funding. I think you guys have it much harder nowadays, but there are still places you can get funding for this postgraduate study. So yeah, I worked on transputers programmed in Occam. That's gone completely. Really, really dead technology. And that's, I mentioned this before, this stuff disappears, but the experience of it stays with you. The way of thinking about it, the sort of more abstracted way of thinking about it doesn't go. That's still true. The way I distributed the control, I would do it in a different way now, but I wouldn't use Occam on transputers. But the way of thinking, partly what the MSc is about is training you to think in a particular way, in a very sort of rigorous way of approaching research and investigating a research problem, doing experiments, writing it up, getting results, analyzing it, looking at what other people have done, all of those kinds of things. So yeah, I finished at the University of Kent. I came back to London, came back to this house actually, and I wrote loads and loads of job applications. I seem to remember sending out something like 150 job applications. Some more targeted than others. Others were just blast off those letters. And one of those came up for me. I got a phone call out of the blue from somebody at the National Physical Laboratory in Teddington. This is the government's physics lab, basically. They do a lot of sort of the physics that the government needs doing, particularly on measurement standards. There was a block that did lots with radiation that I never went into. But I worked in the metrology department. We were all about measuring things. And I was in the pollution measuring department, where I worked on a number of projects, but mainly sort of writing software to process data coming from instruments. I still use the safety boots they bought me because we went to a huge coal-fired power station called Drax, where I had to walk across the coal heaps and collect air samples to see how much gas was given off by the coals just sitting in the open, and how much that contributed to emissions for global warming and that kind of thing. Oh, we had a lovely story. Teddington, it was on the flight path of the old Concorde, the supersonic plane that went over twice a day, and the whole building shook every time it went over. And some of my colleagues were out in the outdoors around the back of the lab, calibrating an instrument that measured airborne methane, methane being a particularly nasty greenhouse gas. And they were calibrating it, and then Concorde went over. And in about 5 minutes after it went over, the plume of pollution it left behind it as it flew drifted down and hit this instrument. And the readings went so off scale, they had to switch it off and go away for lunch and come back half an hour later. And the methane had eventually dispersed enough that the thing could measure in a normal range. So it was kind of a bit of an eye-opener. In our coffee room, we had a live data about NO and NO2 pollution on the roof of the building. And you could see the morning rush hour and the afternoon rush hour. And we'd sit there, and that screen in our coffee room was the National Warning Centre. If it met certain met certain criteria, there would be a broadcast to tell people to stay indoors. So we'd be watching this screen while drinking our tea going, I really don't like the way that line is going up. But there you go. Oh, I learned to program in Visual Basic. Yet another programming language, yet another different type of software. During my MSc, the web had started. Before that, we had the internet. I've had an email since 1988, but the World Wide Web started just as I finished my master's. So here at MPL, there was one room on it was a huge site at the time. It's got much smaller since. There was one room on it where we could go and browse this web thing that was just come out. There were 5 computers on the site that we could use. And I used to go down there and explore this amazing world of web stuff. So keep learning. You've got to, just because you've learned some software or whatever here, it's going to change, and you've got to learn another lot. And the more you know, the more easy it is to learn the next thing that comes along. So I worked there for a couple of years, well, 18 months or so. It was a temporary contract. It was a rolling temporary contract, but it's the best I could find after my master's. And I wasn't sure what I wanted to do next. And my cousin had been doing a PhD at Imperial College and had suggested I go and talk to people there about my interests. And I went for a chat. And they asked me to bring my master's thesis along with me. And I had a chat with a guy called Brian Davis. And what I hadn't realized, that chat was basically an interview, and he offered me a fully funded PhD at the end of it. And I got taken by surprise because I just thought I was exploring possibilities. And there, kind of more or less accidentally, I was enrolled into a PhD. But there you go. And again, I was very lucky to get funding, fees and some living expenses, just enough to live on, really. And I was in the Department of Mechanical Engineering. Actually, it's quite funny because my undergraduate was computer systems engineering, my master's was electronic engineering, and then I ended up with a PhD in mechanical engineering. So all the different types of engineering, but they were all more or less the same thing. Which is something you should think about when you're talking about degree titles and that kind of thing. When robotics falls into all of these. It falls into computer science, electronics, mechanical. And I worked in the mechatronics in medicine lab, where we were applying mechatronics to surgery, medical training, that kind of thing. And my PhD was looking at force information in medical procedures, how we could, if we can measure the force of something, can that help the outcome? And it was a very open question like that. And to address that, I developed, I looked at procedures that use force. And one of them is taking blood from your arm. Many of you will have had this, I guess, where they put a band across your arm and then they feel across the width of your arm looking for a vein. And they do that by pressing against the surface of your arm. This area is called the antecubital fossa. And then they put a needle in. So I thought, well, that's kind of a nice constrained problem that I can look at using force. So I developed a robot to take blood from the forearm. And oops, yeah. And it looked like this. It's a very sort of clunky metal thing, but that was really to test out some of these ideas. So with a PhD, a PhD is a super focused research program of investigating an area. Yeah, I was investigating force in surgery, but you choose a very specialized area, and it can become super specialized, and you investigate that, and it normally takes at least sort of 3 years or so, and then you have some more months to write up what you've done. So you can think of it as yet another kind of, how the MSc was a final year project expanded to fit a year. This is final year project expanded to fit like 3 years, where you investigate this in huge amount of detail and really detailed, and it has to be super rigorous. And at the end of all of this, you write a thesis. So that's my PhD thesis. There we go. In 2000. And again, it's like your final year project reports that you do, where you write up what you've done, and you write in a lot of detail with your results. With, let's see, does that show up? With, error bars and statistics and all of that, depending on your project. Now, if you want to do a PhD, I'm not going to encourage or discourage you, but you have to be aware that you have to focus on something intensely for 3 years. And my conclusion at the end of it all, that it really wasn't suited to me. I'm not that kind of person. I don't like focusing intensely on one thing for such a long period of time. I'm much more jumping around, interested in lots of different things. My attention span is way too short to do a PhD, so it was a real struggle to finish it. And I would advise you, if you want to do a PhD, you really have to be able to focus on something for a long period of time, long being like 3 years, and it's really hard work. But a lot of people get a lot out of it if you're in the right, if it suits you. Something I just wanted to mention, this arm along here, this was to test the needle going into this pad. So basically, I found that if you pressed against the surface of the arm, you could see how the tissue underneath responds to the press in terms of the force it feels. And you can find a vein, because when you press against the vein, because it's a blood-filled tube, it deflects slightly, and it's got kind of an elastic deflection that tells you it's a vein compared to muscle or fat or whatever. And then when you return with a needle, when you push the needle in, the force you're pressing the needle goes up, reaches a peak, and then the needle kind of breaks through the wall of the vein. So the force drops, and you can detect that drop in the force and stop the needle going further. In fact, you can pull it back quickly to stop overshoot. That arm is for testing it, and I made that by taking a cast of my then girlfriend, now wife's arm, and learning how to cast somebody's arm was quite a fun thing to do. But it's one of these things I wanted to add, is that, learn skills that aren't directly in your area. So my PhD supervisor told me off for jumping around too much. But I found actually in the things that I want to do later on, that stood me in far better stead than concentrating super closely on this PhD that I should have been doing. If you're interested in other things, learn some of the things in that. It crosses over in strange ways later on that can be surprising sometimes. So being this kind of medical, that's me 21 years ago. Oh my God. Before beard, before I went white. So my PhD project got taken up by the media because it's that kind of project. They like medical type projects. And I got on a program called Tomorrow's World, which was very popular at the time, sadly missed. And Philippa Forrester, the presenter, came and presented from our lab, and it caused a lot of excitement among my very geeky colleagues. And so it got in some of the newspapers and in New Scientist and all of that kind of thing. And I ended up having to speak to I was on the radio and that kind of thing as well. And you need to be able to talk about what you do. So I ended up talking to various journalists. They came and filmed me a few times and that kind of thing. So you've got to get used to dealing with media as well. And, it can be a really difficult experience. Journalists are desperate for a news item and a really sort of sexy news item. So it can make life difficult. They lie, they publish stuff that I never told them. They made stuff up. Happens all the time. When you read newspapers, a lot of it is completely made up by the journalists. And they blow things out of all proportions. So one of my colleagues was in this lab working on using ultrasound to kill cancer cells within the body by focusing multiple ultrasound sources. And where the ultrasound beams crossed, it would burn a small volume of cancer cells. And he was at the very early stages of working out how you do the vector maths of where to point these sensors. But it got published, and it got published as cure for cancer. So my supervisor ended up getting endless calls from people who were dying from cancer saying, can you please operate on me? And he was going, well, it's a student project. It's, it's not ready. I don't care how ready it is. I'm going to die if you do this. And he'd have to go, sorry, there's nothing I can do. And he said it was a horrible, horrible experience. So, be very careful when you deal with media. They have their own agenda, and you have to be careful how you deal with them. Anyway, on that. Yes, so some venture capitalists got interested in developing this as a product. The idea of moving it to a handheld device, phlebotomists, people who take blood, could use to take blood from your arm. And I went down that path a bit, and it looked more and more horrific. I absolutely hated the idea. Setting up a spin-out company, venture capital funding, developing it as a product. This might be a dream for some of you, and for people it is. For me, it was an absolutely nightmare scenario. Didn't want to do that at all. And I, for once, had the courage to actually go, no, actually, I don't want to do that. And it's a really important lesson, is to know what you really, really do not want to do. It's hard knowing what you want to do, but it's sometimes easier to know I really don't want to do that. So I left that project behind because I really didn't want to develop that for all sorts of reasons. Oh, have a little bit of fun too. Now, I walked into a room 2 years ago, and the final year students had found this video clip from 2001. When I finished my PhD, I was so fed up with my PhD. I went away and made a robot to take part in Techno Games, which was a TV program at the time, competition making racing things. You might think it's an odd way to relax, but the PhD prevented me from doing the stuff that I really like doing, like making stuff. Oh, I'll just show you. Look at who's this person here. Oh my God. So that's me in 2001 with yeah, my girlfriend at the time, who's married later. And it took we took part in this race with my swimming shark, which didn't do very well because it got attacked by this Barbie horrific contraption. And but the judges quite liked it. And what's quite, oops, the video's not. And what's quite nice is the two judges then, Noel Sharkey and Martin Smith, I ended up meeting later at conferences, and Martin for a time worked at Middlesex, so it's kind of nice to say, you were judges when I did Techno Games. But I do realise that's, oops, that's a long time ago. Anyway, that was a bit of fun. Always like making stuff for fun. That's not how you spell stayed. Why on the earth did I do that? I stayed on at Imperial to do postdoctoral research. So I realise I'm running out of time very quickly. Postdoctoral research is a little bit like doing your PhD, but you're working on a specific project for a limited set of time. Your output from that is writing papers, because a lot of the academic research world is focused around writing academic papers, getting them published in journals in particular. One of the projects I worked on was developing a haptic virtual reality training system for surgery. So it was this kind of system which was training surgeons to do operations in the knee, where they put a probe in the knee and a scope on the other side and look inside the knee. And that part of the system was being done by the University of Sheffield, a team up there, nice bunch of people. And me and a PhD, I was a PhD student, worked on this device here, this sort of mechatronic system at the front, 4 degrees of freedom, that you could hold on to, move around, so that would move the probe on the screen, in, out, rotate, up, down, left, right. And as it hit the virtual model, the model in the virtual reality, you could feel that force on the handle as you moved it. So it's as if you were holding onto the tool and hitting the knee joint inside. So that was to train surgeons to not hit the knee when they're doing the operation for real, because it's quite a tricky thing to learn. So there's this sort of area of research in doing sort of training systems for surgeons. But you can see I really enjoy the kind of mechanical design of this and control of all of that. And you know, the first time you fire it up, and you've done all the vector calculations and all of that kind of thing, but the first time you fire it up and you actually do go forwards with the probe and you hit something in virtual reality, and you actually feel it, and you can follow the surface of the knee by feeling the surface round. It's amazing, you know, it's a real sense of achievement that you go, you know, I know what's going on there. I'm taking triangles and working out the normal to the vector of the tool to the triangle, and the force coming back is in this angle and that. But, you know, when it works, it's great. Oh, I keep pressing the wrong thing in Prezi. So get used to working in groups. So this was a collaborative project across several universities and in teams in each university. And I really enjoyed that. I really got on with the other people in the group. And you know, working with the medical staff and so on, going to the Royal College of Surgeons and talking to the people who do the training there and that kind of thing was really fun, really interesting. After that project, I did, just check on the time, I did a couple of projects which is developing things to go inside MRI machines. MRI machines, these big magnets, magnetic resonance imaging machines, which use an incredibly powerful magnetic field to image inside your body. And this was developing systems to go in to that MRI and operate on the person inside the MRI. So this was doing prostate biopsy. Prostate is a gland in men that you get cancer growing in the prostate, and you have to take biopsy samples, which means sticking a needle into it, taking a sample, testing it in the lab. You access the needle by going through the rectum. It's a very unpleasant operation. And if you can do it inside an MRI machine, you can see where your needle is going. So we developed this box on the left, which displayed images live from the MRI machine. And we developed the manipulator on the right, the robot on the right, made out of plastics, 3D printed plastics, and piezo ceramic actuators, because it had to be non-magnetic, because you can't stick normal motors in a big magnetic field in an MRI machine. And the urologist could look at the screen and she'd go, I want my needle to go there. And the robot would move, position the needle, and it would shoot out and take the biopsy sample inside the man curled up inside the MRI machine. Quite, as I said, unpleasant procedure, but nice project, brought it all together, sort of piezo ceramics, the encoders we had to make from scratch, that control box that has a National Instruments system inside with a touch screen and all that kind of thing, working very closely with medics and urologists and so on. And the output from that is this kind of thing, which is, these are the kinds of papers you publish, and as a postdoc researcher, this is how your success is rated, is by how many of these papers you can get published in the right place, because certain places count higher than others. And that's kind of the academic world of research, is very much based around that. So oops, sorry, I've changed the screen. Work with other professions. We worked with medics, medical physicists, and you have to be able to talk to each other. So being able to talk about what you do, being able to talk about, engineering with non-engineers is really important. I mean, that's true with all kinds of jobs. Writing papers is important when you're doing research. So, I mean, I don't really do much research now directly as a technical tutor, but if I search for my papers, it comes up with a whole list. It also comes up with papers written by somebody else, because my name is incredibly common in Serbia, where my parents originally come from. So Alexander Zivanovic is a very common name, and there seems to be a guy there doing, I don't even know what that means. But this is me, modular approach to MRI compatible robots, 3 degree of freedom device, that kind of thing, engineering requirements, those kinds of things. And then I do these other things on cybernetic sculptors and that kind of thing, which I'll mention briefly in a moment. But I realize I'm running out of time because I whittled on about other things. Hang on. So I left Imperial College after 11 years. I know when it's time to move and change and do something else. I was quite fed up with 11 years of being there. I mean, it was a nice place in some ways, but also not terribly nice in others. And also 11 years in one place is a long time to be there, for me anyway. Other people stay for ages, but I moved on. I went freelance for a couple of years, and I did a whole variety of things going freelance. And I'm going to have to rush through this because I realized I've spent too long. I taught 1 day a week at the Royal College of Art. The short version of that is some of the students I supervised when I was a postdoc went to study at the RCA, and then when they had technical problems, they would come back and ask me about it because I was happy to talk to them about it, and they told their friends. So somebody at the Royal College of Art realized that they needed somebody to come in and help them, and they said, the students had recommended you, would you like to come in and work for us a day a week? And I was like, yep. And that was a great job, really enjoyed that. I also worked on some freelance projects. I did a day a week teaching at Goldsmiths College, or again on their Masters in Fine Art program, where they were doing sort of creative tech, really would call it now. I was also doing my own kind of personal research into robots as sculpture, and I taught Arduino courses. This was, what, 12 years ago. Arduino had just arrived on the scene, and because I'd done some microcontroller programming before, I'd done outreach activities at Imperial, I ended up teaching on Arduino courses, and that's where I met Nick. So we taught together on Arduino courses back then. Some of the first courses in the country. I won't linger on. These are some of the projects produced by RCA students. Freddie Yauner is now an academic somewhere, I'm not sure which university. He's a lovely guy. They're a nice bunch. This was one of the projects I worked on together with a sound artist friend of mine. London Zoo, the Reptile and Amphibian House, and she was a sound artist. So she recorded the sounds of these reptiles and amphibians, and I installed a system that would detect people approaching that particular enclosure, and it would play the sounds that she'd recorded. And if there was nobody around, it would play sounds in the distance to try and pull them in and entice them in. And I spent days putting up hundreds of meters of cabling, drilling into concrete. That was super rock hard. But that was there for some years, I believe, which was quite fun. It's another project I worked with some designers, carnivorous domestic entertainment robots. So working on fuel cells that digest animals. So there's a fuel cell in the middle of that table. And the idea is that table leg on the right-hand side has a hole up it. Mice run up the leg, run across the table because there's breadcrumbs or, you know, your old Doritos on the table, and they run over that dip in the middle. And I made a iris mechanism, like on cameras, to open, the mouse would drop in, it would close behind it, and the mouse would die and get digested by this table. Of course, we didn't kill any animals or that kind of thing. It was very much that kind of speculative design of provoking a conversation about domestic products that might take on some life of their own, and you'd have to feed them. This one ate flies on that fly paper. The band had sticky stuff on it and scrape off the flies into this fuel cell, which would power a clock in the base. That was a robot I built to work together with spiders to catch insects in its web, and the robot would go and take the insect and take it into its fuel cell, and it would share the insects with the spider. Good fun stuff. I realise I'm really running out of time. I've had a very long-standing interest going right back to my childhood. Remember, I said things stay with you for a long time. This was a sculpture produced in 1970, so 50 years ago. Computer-controlled, first computer-controlled sculpture, used sound detection, direction detection, and Doppler radar to detect movement, and it was attracted to movement and sound around it, and it interacted with people. And it was made by a sculptor called Edward Ignatovic, and I've been researching his work for, well, ever since actually. And I could do a whole lecture on that sometime. But moving on, I developed some of my own projects sort of based around that. This was a robot that I built for the Dana Center, the Science Museum, which would read your Oyster card, and an Oyster card has a unique identifier on it, and this would move in a gesture in space depending on the card that was placed up on a reader. So every person had their own unique gesture in space. So that was one I developed at home. You know, work outside your discipline. I ended up writing a chapter in a history of art book. I mean, it's a history of British computer art, but I have a chapter published in the history of art book. You know, never even expected that. Another fun project I did, somebody asked me to present something at a Hackaday. This was a Swanee whistle, you know, slide whistle, and some bellows, all made out of junk. That's a car electric window and some air ducting and a printer head mechanism. And I got it to generate sentences by blowing through the slide whistle. So when it was depressed, it was like, ooh, ooh, sounds. And then when it got excited, it'd be, ooh, ooh, ooh. So you could stand there and have a sort of conversation with it as it went through different moods. As you approached, it got more excited. It was just a fun project made out of junk. Always preferred making stuff. Do things for fun. It's the only way that keeps you sane. If you can make your work fun as well, that's a bonus, but it's not always possible. So all my freelance work came through word of mouth. So if you end up freelancing after when you finish, make sure you network, not by, I went to a networking event where people kept handing out business cards like machine guns. And that's not the way to do it. Just talk about the work you're interested in, listen to other people talking about their work, be interested in what they're doing, be interesting about what you're doing. Don't push your stuff onto other people. But all my work came through other people being asked to do something, going, that's not really my area, but I know Alex can do that. And I would do the same. I would go, not my kind of thing, but James knows how to do that. So I'm still friends with people like that. Try and carve a niche, get known for one thing. Be able to do lots of things, but get known for at least one thing. And be versatile. I mean, I took all sorts of weird jobs and projects on that I don't have time to go into. But the main thing is, if you're freelance, charge enough to your clients to live on. I was terrible at the finances. I could not make enough money doing this, mainly because I often didn't get around to actually charging people for the work I did. Just crazy. Don't do that. If you're freelancing, be serious about how much you charge. I was not made to freelance. So I ended up joining Middlesex in 2009. My PhD supervisor, Brian Davis, was an external examiner here, and he heard about a job coming up, and he said, oh, I know somebody who could do that. And he passed on the details to me, and I applied, and I got in as a senior lecturer, and sort of helped set up the design engineering suite of programs back then. I've still managed to do a few projects, and very quickly in the last couple of minutes, some years ago now, I worked again with a friend of mine that I knew from when I was freelancing. We did an installation at Tate Modern, which was a giant delta arm hanging from the ceiling in the dark. There's a difference between how children and adults. In the dark with this lit sort of tetrahedron at the end that would move around, and it would detect people using Kinect cameras, and this would hover over their heads and kind of move as they moved around the space. And it was together with a sound installation to generate this kind of mood of this sort of strangely sort of mystical glowing light above the heads. And that was a very stressful project to work on, I have to say, especially when you're trying to do the rest of your work. But it was interesting, learned lots of things. Oops, I've done the wrong thing again. So still interested in the robots as sculpture. This is another view of the work of this artist, Edward Zivanovic. This is a sculpture that moved to sound, built in 1968. And a few years ago, I worked with a group at the V&A to scan it and make a 3D model of it. So that's the original, and that's the 3D model I printed 1-to-1 scale, to kind of start talking about how objects like this might be conserved for posterity when they're moving objects, and it's very hard to keep them moving and keep them preserved. And there were a few other projects. You know, Smash Fest is always fun. And a few years ago, Win and I built a planetarium inside a geodesic dome, where I ended up doing astronomy shows, because astronomy was really my first love as a kid. So I kind of went back to that. So as I said, you often end up going back to things that have interested you your whole life. So that's a very quick kind of run through my life with a few bits picked out, but each one of those could go off in another direction as well. So I'll leave it there and open for questions. Sorry, I've run out over time, but.
No, amazing. Thanks, Alex. It was a really interesting lecture on your background, your beginnings, your journey, like throughout academia, your own interest as well. And thanks for weaving your insights, stories, and lessons throughout the lecture and talk as well. So thank you. Guys, feel free to gather your thoughts, your questions, your comments in the chat. And as usual, if you want to go online and if you want to go live and interact with your questions and sentiments, feel free to put in a request there as well. Yago Gonzalez, he asked, how many programming languages do you know, Alex?
Oh, I don't know. I mean, it's a very hard question to answer, because you learn some, you get really good at them, and then they go out of date and you leave them behind. And, you know, if you ask me to program in, I don't know, Visual Basic, I haven't programmed that in 20 years. I couldn't do it now. So you move on to another thing. So you have your favorite languages of the moment, and it moves on and you learn the next lot. So I'm a little bit behind in learning Python. So I've been playing around. The Raspberry Pi have released Pico microcontroller, which you can program in MicroPython. So I've been playing around with that recently when I've had a bit of free time, and, you know, learning another one that I've not learned before, but leaving behind the older ones. So I wouldn't like to try and count them, because it doesn't really mean anything.
Amazing. And Zoltan's asking, have you ever used Turbo?
I know.
So say that again.
Zoltan Toma, he was asking, have you ever used Turbo Pascal?
Pascal was the first language we had to use as undergrads. Pascal was the language they taught us on, and then we changed to C and C++, and a language called Z. No, Z was for, no, anyway, it doesn't matter. Functional programming languages.
Awesome.
World.
And now, right, this is a question on your development of the haptic robot to take blood samples from the forearm.
Yes.
So Zoltan and Morgan, they're both asking, did you get around to testing it on yourself?
I did, actually, which was really, really naughty, and I really shouldn't have done. And I would have got my wrist slapped really badly. But I did actually, because I went on Tomorrow's World. They said, well, you can test it on yourself then. And I was like, okay. And I really should have said no, because that's so badly not ethically, it's a terrible thing. So no, and certainly nowadays you certainly wouldn't.
Amazing. And Adam Painting's asking, additive manufacturing is becoming really incredibly accessible for consumers for a variety of applications. So what are your thoughts with regards to the future of this technology?
Yeah, I mean, I first used additive manufacturing in 1998, 99. And, you know, it's been around a long time, but it's become really useful now. In the past, it was used for like prototypes and that kind of thing. But, you know, using them functionally, we like the probe that we had to put into the patients doing the prostate robot, that was 3D printed. The actual prostate robot itself was 3D printed because it had to be made out of plastic rather than metal, you know, machined out of metal. So yeah, there's a big future for it, used in the right way. You know.
Awesome. And the final one, I guess, Julian, is more of a comment than a question. He said that he's pretty sure that he saw your tetrahedron arm light installation at the Tate. So he said it was insane.
Cool.
Awesome. Any other questions, guys? Feel free to type it in the chat or request if you wanted to go live. And
have you got any pictures of the robots? I was just saying that to Andy at the beginning of this. It's funny when you go back, you know, before smartphones, we didn't take photos of much. I have very few photos of things that I've worked on over the years. Even with smartphones, I'm not very good at recording them. I mean, a bit of advice to everybody is just keep taking photos of what you're working on at all stages of it. Don't think I'm going to finish it and then take proper photos at the end, because as soon as you finish it, you move on to other things, or I do anyway. And I'm really bad at documenting these things. And it comes back to bite you later. So that one bit of advice is always take photos of what you're working on. Doesn't matter what stage it's in.
Awesome. Aurel Marianne's asking, what's the name of that shark robot and the event?
Oh, the event was called Techno Games. It was a TV series people could take part in. It's a bit like Robot Wars at the time. It was the similar kind of thing. And I called my shark Gums because it was a shark with no teeth, which I thought was funny, but nobody else got the joke. But there you go. I was never a comedian. Yeah, I called it Gums.
The opposite of Jaws, right?
The opposite of Jaws.
Amazing. Alex, thanks a lot for the talk and taking out the time as well to join us this evening. It was a brilliant talk, and yeah, it was called all students, staff, alumni, participants. We really look forward to seeing you guys again next week. So keep an eye on your emails for the details of the next speaker and links to the next talk. And until next time, stay well, stay safe, and thank you guys.
Thanks for coming. Thanks for listening.